Hello, so today we are going to take a look at this Leetcode problem, type k frequent elements. This is part of Leetcode April challenge. I think it's April 8 or 9, and the problem says that we get an array of numbers and then integer k, and we want to return the k most frequent elements. So the elements that occur the most, we want to take the k most frequent ones. And so, for example, here k equal to 2, so we want the two most frequent ones. And so 1 occurs 3 times, 2 occurs 2 times, and 3 occurs once. And so 1 and 2 are the two most frequent ones, so we input that. With only one element, the most frequent one is that element. So this is the problem. Now how can we solve it? The first thing with Python, if you are using Python has this thing called collections library that has a counter function, and what counter does is exactly what we want. It counts the occurrence of each element, the number of occurrences of each element. So if we go here to the terminal like this, and just take our array here, what counter, and then import counter from collections. If we do from collections import counter, if we do counter of a, then that will give us a map, right, of the number and the number of its occurrences. What's interesting is that counter also has a function called most common k elements, so something like most common, where we can pass how many how many common elements we want, like the most frequent elements, how many, so we can pass k, and that would be exactly what the problem asks us to do. And so we could just do that and pass most common k, and of course let's say 2, for example, in our case, and that gives us the element, a tuple of the element, and then the number of its occurrences. And so now we just need to go and get walk through the list and get the element, so 1 and 2. So that's what we can use here. So that would be, first we need, I'll just do it like this, counter of, I'll switch this here over, so we need counter of a, and then from there we can use the function that we have, most common k elements. And since that gives us a pair here, so we need to extract it, right? So this would be frequent elements. Frequent. Let's just leave it at that. And now we just need to walk through frequency here. So we want the first element, so that x of the 0 for x is infrequent. And then we can just return that. So if you run this, it passes the test cases, so let's just submit. And that passes. You could, of course, like just simplify this for here and make this one-liner. Not really a big deal, but it should pass. Okay, so now next we'll take a look at how we can do it without using this most common function. Just adding a restriction to see how we can solve it. Okay, so how can we solve this without the most frequent function? So we can maintain getting the counter. So the count would give us, for example, for this, it would give us that 1 occurred 3 times, 2 occurred 2 times, and 3 occurred once, right? And what we want is to get the two most frequent ones. So what we can do is actually just use a min heap, max heap, so that we can get and have the keys be the frequency, right? So here we have value and frequency, and so what we can do is maintain a max heap and have the key be the frequency or the number of occurrences. That way, every time we extract an element, it's the most frequent one. and then the second time we extract, it's the second most frequent ones, and we keep going until we reach k. So as long as we maintain a heap, a max heap, we should be good. And so how do we do this? Well, so we can just use the same counter that we used before. For this would be our array here, right? So this would be our counter, and then we can just go through the values, go through the key, and so this would be the number and then the frequency. We can go through these in C and just add them to a heap, and with Python we can use a heap queue to push element. One thing though is, how do we turn it to max heap? In Python it's by default a min heap, and so to turn it to max heap we can just use minus the key, which is the frequency. And so to add to the heap we push, we need to push, this is not the right syntax, the right syntax is heap push, and we need to push just we want the key to be the frequency, but we want to keep track of the value, and so we can just push a tuple. And Python by default, the heap queue, if you give it like x and y, it will use x as the key, and it will maintain y there, so that we can get it later. And so here we can just do minus frequency and then the number here. That way basically when we extract, the first element that we pop would be the max element, because we can just put minus in front. So this is the main idea here. Maintain a heap, add the frequencies, have the frequencies be the keys, and that way basically we'll extract first. In this example we'll extract first 1, right, and then we'll extract 2. Yeah, so this is the idea, so let's code it up. Okay, so let's code up what we just said. So we are going to use a heap queue, a max heap, to keep track of the frequencies and then take the most frequent ones. So we are still going to use our counter here, and then we need to go through the values here. So we would have the number first and then the frequency, and this would be in items. And now what we need to do is, of course, have our heap, and we are going to push. So in Python it's heap push. We are going to push to h minus frequencies, as we said, to get a max heap. And then the next step would be, now that we have a heap with the values in the right order, we can just go through them and get the result. And so that this way basically we would have, so what we said here is we want to keep track of both the frequency and the number, so we need to pass a tuple, and Python by default will use as key this value here, the first element. And so this would be, we'll get key and value from h. Or actually what we can do is, while the length of res, right, is less than k, we want to extract k elements, we can do heap queue dot heap pop from h, and now we want to add that to the list, right? We want the most frequent elements, but what do we want from h here? We get a tuple, right? And so what we want is, so we get a tuple of key value, and the frequency is actually minus k, because this is what we added minus here, so we need to cancel it out. So but actually it doesn't matter, because we only are interested in the number, right? And so it doesn't matter for us here, and so at the end we can just return result. Okay, so this is number. Okay, so that passes. One thing we can do here is, actually we could just return instead the list directly here instead of doing the calculation. So that would be something like just pop, right? And take what we want is the second element, so that would be 1. And this would be for, we want to pop k times, right? And so we can just do range of k and just return that. And that will do the same thing. And we can submit this. And that passes as well. One thing though that we can do is that you can notice here that we only need k elements, right? That's the only thing. We only need the k most frequent elements. So we don't need to go past, to store more than k elements. So here, while adding, if we reach k, then we want to pop the smallest element, because the least frequent element, which is the smallest element in the heap, and so we can just do heap q that heap pop if we exceed k. Now we know that we have at most k elements, so we can just do we can just do the length of h, right? And that will be the same thing. So we can do that, or we could also just return as many elements as there are in h, because we know we maintain an invariant here where we store only the most frequent k elements in the heap. And so we could just say we want the value, right, for in h. This is what we want, right? So if we run this, so we get a key and a value in h. Yeah, so since we want to pop the smallest, if we do pop here, we'll pop the max. And so we can just modify this to be a min heap. And now every time we reach k, we remove the smallest elements. And then at the end, we can just take the number. So take the numbers that are in h, because we know that we maintain that the heap contains the most frequent k elements. And that way we can just, so this should work. And we can submit. One thing to note is that the order doesn't have to be the same, and this passes. In terms of time complexity here, so this is done in oven time and oven space, because we are using a map. It has as many elements as at most the number of elements in the array. So and then here we are doing this loop at most oven time. And then here, pushing and popping from the queue, that's usually of like k, because we maintain that the heap here contains at most k elements, and so we have of like k for push and pop, and so overall the loop here is of n like k times, and so here we return a list as well, that is at of k. We go through a list that it has at most length k, so this is of k time, of k space. So basically, overall, what this would mean is that our time complexity here is O of n plus n like k plus k, right? And so the dominant term here is n like k, and so this is our time complexity for the solution. If we take a look here at the problem, it says that the time complexity must be better than O of n like n, and that's what we have here. K is necessarily it has to be smaller than n. Yeah. Okay, next we'll see how we can solve it in another different way. Okay, so another thing we can do just to make this even simpler is we cannot rely on counter. Let's say we are in a language that doesn't have it. We can actually just use a map. So we can do, this is our map. One clever thing we can do is have the default value be an integer, so that any key we use will have a value 0 by default. That's what happens if we do this. I can show this quickly here. So if I need to import collections. So if I have default dict, it's called, sorry. Now if I do any value, it's 0 by default. I don't need to initialize it. It gets initialized to int 0. So this is default dict. And now I just need to count myself. So for a in a, we can count here. So m of a plus 1. And then now we could just use that. We can just call this count. And it's still the same time complexity. It's oven, so overall this is oven like k. And this passes. Yeah. Okay, so another completely different way we can solve this, not using a heap, is which is more optimal actually, is using an idea from bucket sort. The idea is basically, or you can think of it as maintaining buckets of frequencies. So let me take the first example that we have here and do an example on that. So the idea here is that we will maintain an array of frequencies. So we would have an array here, and where the indices are the counts or the frequency of occurrences of each element, and the value is the a list of elements that have that frequency. What this basically means is that so here, okay, let me actually put a larger space. So we'd have here, 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 and maybe something like this. So basically what this would mean is that 0 will contain elements that occur 0 times. We'll put them in a list here. And here the elements that occur 1 time, we'll put them in a list. Elements that occur twice, we'll put them in a list here. Those that occur 3 times, we'll put them in a list. So you can think of it, we could use a map, right? But it will be simpler using an array. We'll see later why. And then here we'd have 4. Yeah, we could stop here actually, because the most occurrences that we have is 3, but we could have an array, let's say, that has all elements 1. And so the most, in any configuration, the most number of occurrences would be the length of the array, right? And so what this would mean is that here we need to go 5 and then 6, which is, that's the length of the array, okay? So the elements that occur 5 times, and then here are the elements that occur 6 times, which we would use if we had an array like this. Okay, so let's start on this example. So we have 1, we find that it occurs here, and then it occurs 3 times, so we add it here. We have 2, it occurs 2 times, so we add it here. We have 3, it occurs 3 times, so it occurs 1 time, so we add 3 here, right? And so how would we do this? So we would have the counter first, and then loop through the counter, and basically just do, so this array, let's call it maybe buckets, right? So for our buckets, so we will have a counter like we had before, which would be the counter of occurrences of A. We can use a map ourselves, or we can use Python's counter, and then just go through. The key would be the value, and then the number, and then the value would be the frequency, right? And so here our buckets, the index, remember the index is the frequency, and so we'll just pass frequency here, and then we will add the elements since it's a list. Now once we have this, how would we get to the most frequent elements? I'll show you later how would we initialize buckets, but how would we get the most frequent elements? All we need to do is go is flatten the list. So if we flatten it, we would have 3, 2, 1, and the ones at the end, those are the most frequent ones. The k elements at the end, those are the most frequent ones. Why? Because the index represents, the higher index represents more frequency of occurrences. And so if we had any element in 6, that's the, for example, in this array, we'd have 1 in 6, that's the highest, the most occurring elements, right? And so we could just go through from the right to the left and pick the k ones, and then whatever k elements we have, those are the most frequent ones. So flatten the list and then get the most frequent elements. We'll write the code later to flatten the list, but so we could just do flat list, and that would be flatten buckets, and from there we can just take the last k elements. So we need to reverse the list. In Python we can reverse it with this, and then take the k elements. So either we can do a loop and go from the end to the start, or we can just reverse it, so we'd have 1, 2, 3, and then take the first k elements. And that's the main idea here. Now let's code it up so that it's more clear. Okay, so let's write what we just saw in the overview. And we need to initialize buckets. And so we said the values are empty, are lists of the elements that have the frequency, the index, and so we need to initialize it to an empty list. And so we will need the list length to be length of a plus 1, right? Because the 0 element has nothing, right? Because frequency is 0, that's an empty list. And from there we need to go through the key is the number, the value is the frequency, and then we want to go through the items. And for the buckets frequency, since we initialize it to empty list, we can just do append, and we want to append the number that has that frequency. So now we have our list with the indices are frequencies, and then the values are the lists of elements that have that number of occurrence. Next, we want to flatten the buckets so that we can get the last k elements. And so to do that, we can just do initialize a flat list here, and then just go through the elements in buckets, and then just add list. And now once we have flat list, we can just reverse it first, right? So that we can take, with Python we can reverse this way, and we want to take the k elements. And once we reverse, taking the k element is just the last, the first element are just the last k elements once we reverse. So we can return this. And let's submit. And that passes. Another way we can do this flatten here using list comprehension is we can just do flat list is equal to, we want to get all the elements for x in list and for list in buckets. Except for to find list, we need that to be defined first in the list comprehension, so we need this to be like this. And if we can run this, and that should work. If we submit, that works as well. In terms of time complexity, we know that this is already O of n time, O of n space. Same thing, buckets here is at most length of n, so O of n time to initialize it, O of n space as well. For this loop, this is O of n time. And then to flatten the list, same thing, we have at most n buckets, and so O time, and O space as well. And to reverse, similar thing, O time, getting the k elements is O time as well. And so overall, this is O time, O space. Yeah. So yeah, so this is another way to solve it using this idea of buckets. Yeah, so that's pretty much it. Thanks for watching, and see you on the next one. Bye.